Good morning, student. Let's start today's class. Okay. In today's class, we are going to study about the another modulation technique or another technique we used in analog signal to digital analog data to digital encoding techniques, that is delta modulation. Okay. In previous classes we have already seen about the PCM, pulse code modulation, and now we will see about delta modulation. Before that the note down the bandwidth of PCM. Okay, the bandwidth of the PCM, that is the minimum bandwidth or the at least bandwidth or the minimum bandwidth of the PCM is NB into bandwidth of analog. NB is bit per sample, okay, and the bandwidth of analog is a bandwidth of the analog signal given, okay, or input analog signal. Okay, note down that bandwidth of the analog signal. Okay, sorry, bandwidth of the PCM signal. Now let us discuss about what is delta modulation. Okay, since we have PCM modulation, why we use delta modulation? So there are some disadvantages. There should be some disadvantages of PCM modulation. That's why we use delta modulation. What is that disadvantages? Okay, since PCM is very complex technique, okay, and delta modulation is a very simplex technique, because in PCM there is so many process. Okay, one is what one is sampling, one is quantization, then encoding. There is three process. Okay, so that it is a very complicated techniques or complicated encoding techniques. But here in the case of delta modulation, it is very simple, because there is no three process or only one process is there. Okay, and in the PCM modulation we use 4 bit per sampling. That means 4 bit of coding. In previously you see the one sampling is represented into 3 bit or 4 bit binary code. Okay, that is 2 for quantization code 2 we use binary representation of 2, that is 0 1 0. Okay, so if we use 3 bit, at least 3 bit for one sampling, and if we sample a analog signal, let's say a analog signal we sample or sampling number is 10, and the bit binary bit per sampling is 3. that's that is or that's equal that the analog signal encoded in 30 bit. Okay, and you know, for better performance or uh, better encoding, we use high sampling rate. That is, we sampled very frequently. Okay, or we sampled very consecutively, so that the bit rate also increased. So uh, to send that bit rate in through the media, we need high bandwidth of channel. Okay, or bandwidth of the channel is very high, so very cost effective. Okay, sorry, so very expensive to get that high bandwidth channel. So for recovering that these problems, we use delta modulation. Okay, so in PCM modulation, in PCM, sorry, the PCM finds the value of signal amplitude for each sample. Okay, but in DM finds the change from the previous sample. Okay, that means in PCM the amplitude of every sample is there, but in DM the every sample is not needed. The needed is that the or the comparison in DM. What happened, the comparison of previous to the upcoming sample is needed. Okay, now see what is the process of delta modulation. Okay, in delta modulation what happened, you see, first of all what happened in delta modulation, this is our analog input signal. This is our sorry this is our analog input signal. Okay, and first of all in delta modulation we approximate that analog signal to a staircase function. What is staircase function? As name suggests, the staircase function is having up and down uh, manner, or up and down function. Okay, this is called staircase function. Okay, and this staircase function is that means that staircase function, how the staircase function is represented. And first of all see, this is the time, this is the ts or sampling time. Okay, this much vertically. Okay, and the horizontal one unit is delta, this delta. Okay, that is step size. Okay, one step, this is one step. Okay, now see how the delta function, how the staircase function is made from the uh, analog signal. This is the rule is that when the staircase function compare with the amplitude of upcoming uh, or amplitude of the analog signal, and get that the amplitude of the analog signal is more than the amplitude of or the level of voltage level of staircase, then one unit, that is one delta, is increased upward. Okay, and uh, and when the amplitude of the analog signal is less than the staircase levels or the voltage level of staircase, then the staircase is one unit, that is delta, uh, downward. Okay, now let's see here. First this level is okay. First of all this level of staircase, and now it compares with the in the analog signal, that the analog signal amplitude is very high, so it upward one unit. Okay, one unit, that is delta. Okay, then yeah, at that time it compare with the analog signal. Okay, that so and see that the analog signal amplitude is higher than the staircase voltage level, then it one level upward. Okay, or one unit upward. Okay, then here also it compare, then it one unit upward. Okay, here also it compare, then one unit is what upward. Here at that point it compare with the amplitude and see that the amplitude of the analog signal is less than the voltage or level of the staircase signal, then it downward one unit. Okay, downward one unit. At that time it also compare and downward one unit. That's like it downward. And here what happened, it compare with the it compare with the analog signal. See, this is the higher, no, the analog signal amplitude is higher than the uh, staircase level. Okay, previous staircase level. Always compare one point is there. Always compare here. Always compare the uh, present staircase or the previous staircase level with the upcoming amplitude of the uh, uh, analog signal. That means this level always compared with that the next amplitude of analog signal, and this level is compared with the next amplitude of the analog signal. So here this level is compared with the amplitude of the next level of the analog signal. So it is higher than the level, so it one end up and one end up and down. Okay, so this is our staircase uh, what staircase function. Okay, this is our staircase function, and after that staircase function, since the staircase function is not uh, accurate as like our analog signal, okay, so there is some error are there. So that for resolving that error, we use a method, or we use a what universal method or a stable method, that by representing that what that staircase function into binary equivalent binary bits. Okay, that when and the rule is there, when the when the staircase is upward directed, that is represented by 1. Okay, when the staircase is downward directed, that is represented by 0. Okay, 0. You see here uh, from this is 0. Okay, first one is 0. From this to this, from this to this, the staircase is upward direction. Okay, so this is 1 1 1 1. Okay, and from this to this much, okay, is downward direction. Okay, so 0 0 0 0 0 0, and again this is upward direction, so that it is 1 1, and downward direction for 0. That means in each every bit, okay, in every bit you see, since this is upward direction, this is 1. Okay, and this is upward direction, this is 1, and this is upward direction, and this is 1, and this is upward direction, so that this is 1, and this is downward direction, that why it is 0, and after that it is also downward direction, so that 0, and similarly we get the digital output or digital data from the analog signal. Okay, that is the uh, that is the concept behind the delta modulation. Similar thing written here, you can study. Okay, and now see the modulator. This is the modulator. Okay, or transmitter. In the transmitter side, this much happened. In the receiver side, this much happened. Okay, in transmitter side, what happened, the analog signal is fed to a comparator, and this is the sawtooth this is the staircase function. Always compare the with the staircase function, and uh, and after that after comparing, we uh, plus one delta level or minus one delta level, and one delay input delay time is there, and again that staircase is compared with the analog signal, and by that way we get our binary input. Okay, sorry, binary output. Okay, this is the transmission side. Okay, and in the receiver side, this binary output is binary input for the receiver. Okay, and here that convert that 1 and 0, 1 and 0 into plus delta level and minus delta level. That means for binary 1, okay, represent as a plus delta level, and for binary 0 represent as a minus delta level. In the previous, that is the process which is happened in the transmitter side is in reverse manner happened in the receiver side. Okay, that's all. Thank you.